All right. The easiest way I have found to graph log functions is knowing that it is the inverse of the exponential function. So if I have x, my base is 2, and then I have 2 to the x. I'm still going to use negative 1, 0, 1, and I'm going to use 1 half, 1, and 2. But now the log is backwards, so the points on my log are going to be log base 2 of x is going to be 1 half, negative 1, 1, 0, and finally 2, 1. Okay, so I have 1 half, negative 1, 1, 0, and 2, 1. And I know the general shape of the graph, and I have a vertical asymptote there. But what this tells me here is it's shifted to the right 3 units. So that means I'm going to start with my asymptote. My asymptote was here, so I am going to go to the right and draw my asymptote here. Then I know each one of these points, I'm going to move 3 to the right. Whoops, that should be here, not there. So, and the graph should have the same general shape. Okay, so graph the following and include any horizontal or vertical asymptotes. So I have a vertical asymptote at x equals 3. Okay, if I have g of x equals log base 3 of x plus 7, I'm going to do exactly the same thing. Well, I know I have my x and I have my 3 to the x. So negative 1, 1/3, 0, 1, 1, 3. So if I have log base 3 of x, it's going to be 1/3, negative 1, 1, 0, and 3, 1. Okay, so that's my parent function. So let's see. 1/3, negative 1, 1, 0, and 3, 1. Okay, so here's my parent function. And I know that this is going to shift up 7. Okay, so that means that my vertical asymptote remains where it is. So I have a vertical asymptote at x equals 0. And then I just move each of these points up 7. So that goes to 6, that goes to 7, and that goes to 8. And there's my function. Now again, a lot of this is always teaching tools. If you can jump straight to it, that's fine. Okay, but you remember you do need to have some specific points in there. Alrighty, let's look at some log properties and do some expansion. Remember the rules on this. Okay, I'm not going to repeat it. Well, let's go ahead and just as a refresher. So my rules are log base b of xy equals log base b of x plus log base b of y. Log base b of x over y is equal to log base b of x minus log base b of y. And I didn't leave enough room here. My other one is log base b of b to the x is equal to x, I'm sorry, of x to the y, is equal to y times log base b of x. Okay, well, I screwed that up. Okay, so if I look at this, I'm going to look at each of these and figure out how many bases that I'm going to have. How many things are raised to powers? Do I have a number? Do I have a variable? Do I have a different variable? What exactly is going on? And split it up. And then also, is it multiplication or division? Okay, so this one I'm multiplying, and here's my argument here. And I can split my argument into 27, x to the second, and y. So I'm going to split this into 3 logarithms. So log base 3 of 27 plus log base 3 of x to the second plus log base 3 of y to the third. And then I'm going to look at each of these pieces and see if there's something I can do with them. Okay, well, I know that 27 is 3 to the third. So this is log base 3 of 3 to the third. So this part is just 3. Here, I can use the product rule, and this becomes 2 times log base 3 of x. Here, I can use the product rule, and I have 3 times log base 3 of y. And there's your expanded form. Okay, so here I have log base b, and this is my whole argument here. And I have 3 different bases, so I can split it into the x's and the y's and the z's. So this becomes log base b of x plus log base b of y to the second plus log base b of z to the third. Okay, well, I can't do anything with it. It is just fine. So this becomes log base b of x. Using the power rule, this becomes 2 times log base b of y. Again, using the power rule, this is 3 times log base b of z. Okay, so let's see what I've got here. I have 1, 2, 3, 4 different bases in my argument, and 2 are in the numerator and 2 are in the denominator. For any base that is in the numerator, it's a plus. For any that's in the denominator is a minus. So this becomes log base 5 of 125 plus log base 5 of x to the fourth minus log base 5 of y to the fifth minus log base 5 of z. So let's see what I know here. I know that 125, this is the same thing as log base 5 of 5 to the third. So this is 3. I can use the power rule. So this becomes 4 log base 5 of x. This becomes minus 5 log base 5 of y minus log base 5 of z. And there's your final answer. Okay, for D, I have the log of the square root of all this. Okay, so the first thing I'm going to have to do here is I am going to write this as log of x to the second, y to the third, z to the fifth to the 1/2. Now, there are a couple of ways that you can do this. And the way I would do this is I would say, all right, then that means this becomes log 2 times 1/2 is x. 3 times 1/2 gives me y to the 3/2. 5 times 1/2 is z to the 5/2. So now I have 3 bases. I have my exponents. I can split it into log x plus log, and I'll do it, y to the 3 halves plus log z to the 5 halves. And then I'm going to use my power rule. Okay, this can't do anything with, so this just becomes log of x. Now I can move this around front. Same thing here. And there you have it. And just to be consistent with what we did in class, I'll leave it like that. Okay, this one I'm going to do exactly the same thing. Natural log doesn't mean anything, so let's see. Just if I start out on this, this is going to become the natural log of x to the third, y to the second, over z to the fourth, to the 1/3. So now I'm going to do exactly what I did before. You can do it and do that afterwards, but I'm just going to do it here. So this is the natural log of x, y to the 2/3, over z to the 4/3. So I have two bases in the numerator, one in the denominator, so these two will be plus, this one will be minus. So I have the natural log of x plus the natural log of y to the 2/3 minus the natural log of z to the 4/3. So my final answer becomes the natural log of x. It's just the same. This becomes 2/3 times the natural log of y. This becomes 14. I'm sorry, 4/3. Wow, I don't know where that came from, of z. Okay, for this last one, I may have to write small. We'll see. Okay, so let's see. I've got 1, 2, 3, 4 different logarithms. So I'm going to write this as log base 4 of 64, except I wrote it backwards, plus log base 4 of x, plus log base 4 of y, minus log base 4 of z to the third. Okay, well, I know that 64 equals 4 to the third, so log base 4 of 4 to the third is just 3. This is fine. I can't do anything with it. This is fine. I can't do anything with it. This, I have to move this out front. And I'm done. Okay, well, now we're going to go backwards. And we are going to take an expanded form using the same rules and write it as a single logarithm. So all the bases have to be the same. And then you just combine using, you're going to go backwards. You're going to do your power first, and then you're going to combine them. Okay, so the first thing I'm going to do here, I have base 3, base 3, base 3. So I can combine them all into a single logarithm. But the first thing I'm going to do is move this back up here. So this becomes log base 3 of 5 plus log base 3 of x plus log base 3 of z to the second. Now when it says a single logarithm, I'm going to write the log base 3 only once. Now, since this is positive, the 5 goes in the numerator. This is positive, the x goes in the numerator. This is positive, so the z squared goes in the numerator. Okay, so log base b, log base b, log base b. Okay, so in my first step, I've got to turn this into an exponent. So this becomes log base b of x plus log base b of y to the second minus log base b of z to the second. Okay, so I'm going to write log base b only once. Since this is positive, it goes in the numerator. This is positive, it goes in the numerator. This is negative, so it goes in the denominator. Okay, so I've got plus and minus, so I've got to think about that. I've also got fractional exponents. So this becomes log of x to the 1/2 plus log of y to the 2/3 minus log of z to the 2/5. Okay, so I can write the word log once. This is x to the 1/2, y to the 2/3, since both of those are positive, z to the 2/5 in the denominator. Now, it doesn't say that you have to simplify this, but if it asks you to convert this to radical form, then this becomes log of x to the 1/2 is the square root of x. Y to the 2/3 becomes the cube root of y to the second. Z to the 2/5 becomes the fifth root of z to the second. Okay, same thing here. This one's going to take a little bit more work. I'm going to move these, this, and this. So I have log of x to the 1/3 minus log of y to the 1/3 minus log of z to the 2/5. So this becomes the log of x to the 1/3 over y to the 1/3 z to the 2/5. So that becomes the log of the cube root of x over the cube root of y and the fifth root of z to the second. Well, I can put these, since the indexes are the same here, I can put that under the same radical. So, and again, you don't have to. In fact, I don't know that I would or not, but this becomes the log of the cube root of x over y times 1 over the fifth root of z to the second. And there's another way to write that if you look at it. Okay, this one is very, very similar. So I'm going to skip the first step. I'm going to go straight to, this is the natural log of x to the 1/2 plus a natural log of y to the 2/3 minus the natural log of z to the 2/5. So this is the natural log of the square root of x times the cube root of y to the second divided by the fifth root of z to the second. Oh, and this is the same as this one, it's just using a natural log. Okay, now there are a couple of ways that you can think about this one. Each of these is multiplied by 1/2. So you can think about this as writing it as 1/2 times the natural log of x minus the natural log of y minus the natural log of z. So this is 1/2 times, if I combine these now, the natural log of x over yz, which gives us the natural log of x over yz to the 1/2, which is the natural log of the square root of x over yz. And we will quit there.